Okay, so this is the follow-up to the first GIS lecture. This will be useful for you guys in your project, maybe milestone 2, I think, which is why Jacob asked me to do this. We're going to go through, thank you, Tina, adding data again and then creating a shapefile of your own. So how do you create a shapefile? How do you create points? How do you create lines? And then we're going to talk about measuring line lengths, calculating your line lengths so that you can store it on a table. And then we're going to begin talking about buffers, which we discussed in class. It will just be those buffers around stations, which we use to represent our catchment area. Okay? So you're going to understand how to calculate the populations within those catchment areas for your lines that you can learn how to draw. So this is how we do it. I'm actually going to start a new GIS map, and then this will be my backup. So we're going to create a new map document. Let's save changes to the example I was playing with earlier. So great. Okay, we have a new map. I have a few toolbars here that might be distracting, so I'm gonna hide them for now. Okay, so if you open GIS at the Mad Lab, for example, or ArcGIS in the Mad Lab, you're gonna probably see something like this. It's very base or basal. You might have your catalog on your side. If you don't, then I believe you can just like customize and then add catalog somewhere. Your ARC catalog can be accessed via Windows and then catalog. So what we're going to do first is add some data or create a shapefile. So how about we remember that add data button. First, you need to connect to a folder. I've already done it for the tutorial. So in order to connect a folder, you would just hit connect folder and then browse until you find the folder that you want or have all of your existing data in. Refer to the last tutorial video if that's confusing to you. And then instead of, maybe we'll just add, I'm Midgar because that's my project. Maybe we'll just add the population employment so that you guys can see where we are. This is, the KW shapefile that everybody has, but they represent different cities. The first thing we'll want to do in order to kind of begin populating this map with our own information is to actually create a new shapefile. So to do that, you would go into our catalog, which is this window here that I have. And then in the folder that I just added, or in the folder that you've already added, we're gonna do a new folder actually. Maybe we'll create a new folder. We'll call it tutorial. Which is weird to have a subfolder called tutorial in tutorial. Anyway, we're going to right-click on this folder, and we're going to hit New Shapefile. So here we get to create a new shapefile. Under this prompt, you can name it whatever you want. Try to keep it short and no spaces. We're going to call this our new stations. Because say you want to create stations somewhere on your land, and we didn't provide you any means to do that until now. You're going to hit Edit under Spatial Reference in order to set a coordinate system. A coordinate system, again, is where you are in the world. So what's happening is you need to choose a point of reference in the world in order to assign data to it, or assign a point to it. So we're going to go to where we live. And this is kind of, where are we? North America. The standard that's used very frequently in public sector GIS work is the NAD 1983 as the geographic coordinate system. And we'll just use that. You don't really need to know everything about that. Planners would understand that better, but just choose the North American 1983 geographic coordinate system. Cool? And you're probably going to get errors anyway. So now we've created this shapefile. You can see it inside of your folder connections or inside of your catalog. And if you go into the attributes table, then you're going to see nothing because we don't actually have any point data there yet. So we are going to go into, we're going to find a toolbar that will allow us to edit that shapefile. And that is, of course, editor. And I'm sorry, I should have pulled up a new Word document that has gigantic numbers on it so that you guys can follow along. So this is by now 3. I'll post a reference document later. Let's call this 200. No, 300. That makes no difference. That's not a linear thing. Anyway, this is number 3. We're just going to create points. So now we have this editor toolbar. It'll probably pop up like this. You can drag it into your toolbars at the top. So editor allows you to begin editing a shapefile by hitting start editing. That's intuitive. And then click on the layer that you want to edit. So here's the population employment shapefile that we had earlier. That's a polygon file. We're going to edit that station shapefile that we just created. So hit OK. Ignore this spatial reference thing. It won't actually impact you. I'm going to pin catalog here. What's going to happen is now you've opened up this editor, I guess, like state in ArcGIS, and some options become available to you. So the one that we want to click on is Create Features. That's right here. So Create Features, and then you're going to see this Create Features window pop up. You're going to select the station that, the objects that you want to edit, which in this case is just the station point data because we chose that layer. You're going to click on it, and then at the bottom there's going to be construction tools. Construction tools will literally allow you to click anywhere and plot a point. What might be useful for you guys, and I think I already turned it on earlier, is snapping. So just like AutoCAD and any other vector software, you will be able to snap objects to existing ones. So I actually allowed it to snap to points, to ends, vertices, and edges. So I can just hover over and it will try to snap. This might be useful for you because you might want to put it on the edge of something, or you want to put it on a line that you've already drawn. Maybe I should have drawn lines first, but we'll do stations first. So say we wanted a station here. I'm just going to click. I'm just clicking around randomly. These are arbitrary stations. And now we've created, or we haven't finished creating, but we've begun populating this shapefile with point data. So once you're done with all of your new stations, which could be random, but we hope they're not, you can save edits through your editor toolbar, save edits, and then stop editing. Now you'll notice construction tools is empty. There's no templates or nothing for you to create your features on because editor is off. So we're going to close that window. And if you right click on the attribute and look at the attribute table for stations again, you're going to notice that now we have a few new points. There are exactly 4 or 5 because I clicked 5 times. And all of them can be selected like this through the attribute table. I'm gonna deselect them right now, actually. Now, say I want to create a new transit line, and so I need to create a new type of shapefile, which is a polyline. So we're gonna go New Shapefile, and this process is the same. Oh, this is number 4 now. Number 4. We're gonna create a polygon. This is our maybe this is our LRT route. Okay, no spaces, route. And instead of points, we're going to choose polyline. You notice here we can also create polygons. I'm not really sure what the other 2 are because I'm not a GIS expert. So we're going to create polylines. We're going to use the same 1983 North American coordinate system. We'll do zone 17. I also chose the coordinate system for the planners out there. But if you just choose your geographic coordinate system, you'll notice it's the same 1983. Okay. And now we've created an LRT route shapefile, which will contain polylines. So we're going to go back to our editor window. We're going to hit Start Editing. We're going to choose LRT route as the one that we're editing, hit continue, and then we're gonna open create features, and then you'll see here we can actually edit both, but we're gonna edit LRT route, and we're gonna draw maybe lines between all of our stations. And this is a really weird route. Note that when you're done drawing your, one LRT line, double click on the endpoint so that it actually creates it. If you don't do that and just draw a line like randomly, when you hit save edits, it will delete that. So make sure you draw your line, and then at the last station, at your terminal station, where your terminal time is, you're gonna double click, okay? So now we have a line, and we have, and you can actually close editor now. So save edits, stop editing, close this, and we can see in our attribute table that there's one polyline, and we drew it in between, connecting all of our stations, which we could do because we snapped, okay? Great. Now we're gonna do number 5, which means nothing to you guys because you're not looking at my sheet. But we'll put this on learn later. We're gonna measure the line length. We had some questions about people who didn't know how to measure line length. And so we're going to actually open a new toolbar, and it's tools, the tools toolbar. It's this thing right here. It's like magnify, whatever other basic stuff. And it has a little measure tool here. So say you already have a thing on like an object on your map, and you just want to measure maybe the distance, straight line distance, desired line, between your, two stations. You can do that, just like, hover over it and then double click. And that will give you your measurement right here in lengths, okay? If you wanted to measure a polyline, like several points, and then see what the cumulative distance is, then you can just keep clicking and then close it again, or you'll see that it's like, it's dynamic here. It's adjusting to the length of my line wherever it is. And then just double click at the end, and you'll see the total length of that line. In order to record the line length of maybe your LRT line, you're gonna want to do something a little bit different, where you open the attribute table, and just like before, where we learned how to add a field, we're gonna do route length without any vowels, or with just one vowel. And then we're gonna hit double as a number, and we're going to calculate geometry, which is a tool we've used before. But if you didn't know, this doesn't just calculate area, it also calculates lengths when we're looking at polylines. So do the coordinate system of the data source, you're gonna see this coordinate system come up a lot. And then you're gonna choose the units that you want to measure. So maybe we'll do kilometers just because I don't care how many meters it is. And then we're gonna hit OK, do an edit outside of edit session, and that is my total route length. That's my LRT that I just drew, okay? Cool. Next, we're gonna create buffers in the last 10 minutes. This is probably the most important part of the tutorial. Let me change the number. So now we're gonna talk about how we create those, that circle. That's, oh gosh, that looks, and we're going to maybe create buffers around each of our stations, because you can't get off, your LRT line is only as useful as where the stations are. So we're gonna use something called ArcToolbox, which is not a tool that we've encountered so far. If you click on ArcToolbox, or you can also do geoprocessing and find it here. If you open ArcToolbox, you're gonna see a bunch of tools, and I'm gonna not expand that right now. There are a bunch of different tools that you could be using in order to analyze your space. The one that we're going to use is under analysis, and there are all of these like different kinds of analysis tools, and we're going to use proximity because we're going to consider spaces that are proximal to our LRT stops. So we're going to choose the buffer tool, and that creates a buffer around any polygon or point data that you put in. You can actually see on the right side here a really good like visual example of what it does. So whenever you have issues using any ArcToolbox functions, just look on the right-hand side and it will probably give you a guide. What we're going to input is the features that we want to draw the buffers around. So we're going to choose the station's shapefile that we just created. We're going to choose where the output location is. And so I've already done this, but we'll navigate to the example folder, or not the example folder, the tutorial example folder. And then we're going to call it something. We're going to call it maybe save. And then we're going to choose a linear unit that defines the radius of the buffer. So this, of course, could be in meters, could be in whatever you want. But we're going to use something that's convention in transit planning. So our buffer distances represent the capture area where pedestrians are willing to walk to the station. So that's its effective zone. For bus stations, and this is probably something you guys should use in your project, for bus stations and non-rapid transit routes, you might want to use a distance closer to 400 meters because people are generally willing to walk that long to access a bus service. For higher quality service such as LRTs, which is the example here, you might want to use something closer to 800 meters because the quality of service matters, or the level of service matters, and people are therefore willing to walk longer to access faster service or more frequent service. So here, because we're using the example of an LRT, we're going to hit 800 meters, and that's going to be my effective buffer. For the method, we're going to choose geodesic. There's a reason why we do that, but we're going to do that right now, and we're not going to do any dissolves yet. But dissolving means that if you have multiple 800-meter circles that overlap, it'll join those two together into a single polygon. Okay. We're going to hit OK, and then it's going to run. It might show this dialog box depending on what your settings are. I like to see that it has succeeded. And so we can close that, and we'll see that there's a new buffer shapefile. And you can see these circles around all of the stations that I've created. Now, in order to calculate to estimate the number of people in my station area, and I believe this will be number 7, we're going to estimate the number of people in my station area captured within that 800 meters. The problem with doing this is that we have different polygon files that actually underlie each of the buffer zones. So some buffers, if we zoom in here, this might be a good example. This station here is actually caught in between, and I'm going to move the layer up, in between this zone, in between this zone and this zone. There's like that little piece here that is overlapping this zone, okay? Which doesn't matter that much, but is relevant because each zone has unique characteristics. For example, population and employment densities, which you guys might find interesting to include in your project. So I'm gonna move the buffers up top again so you can see it. I just dragged it. And we're going to estimate the number of people in the service area by first dissolving our buffers, which is not super necessary here. You'll find that if we were to do the same thing for all of the ion stations, and I can actually bring in the ion stops right now because I have it readily available, and put it on top. You're going to have a lot of stations here where if we draw the buffers, they're going to create overlapping buffers. So because of that phenomenon, you'll actually want to dissolve. So I'm actually just going to repeat that process, ignoring the LRT route that I just drew, and we're going to use the ion stops. So this is our input. This is just repeating what we just did, ion stops, and we're going to name and place our buffers. So this is going to be called buffer LRT, or sorry, buffer ion. And again, 800 meters, not 8,000, and we're going to choose geodesic. Cool, it runs, and you'll see all of these buffers here. So the issue with that is that we only have one LRT line. There isn't that like multiplicative coverage, like you're not going to get like say you have two station areas that overlap, it doesn't make sense to accumulate or double the population that you have there. So what we're going to do is go into geoprocessing again, go to ArcToolbox, and this time we're going to use the Dissolve tool, which is under Data Management Tools, and go to Generalization, Dissolve. Dissolve will take whatever inputs that you have here. Oh, double clicked it. Whatever inputs, and then dissolve the like polygons. And so we are going to dissolve the LRT roots, or sorry, buffer ions. And we're gonna locate that. So dissolved buff ion. Cool. Just leave everything else default and then hit OK. It will complete. And then we're gonna see that our station, our network coverage is actually this one singular blob in the core areas, and you're going to see these disaggregate coverage zones outside of it. So now that we've dissolved our buffer zones, you're actually going to, it's more necessary now to consider that those like different polygons underneath. What we're going to do is we'll intersect this buffer shapefile with the polygons that lie underneath it. So we're going to kind of like split up. For example, if you go to like the University of Waterloo area, like this is Westmount, this is King, I believe. Then we're going to split up the overlapping buffer along Columbia and along, I'm not even sure what that is, but let's say it's University. And we'll do that by using the Intersect tool, which is another thing in the ArcToolbox. You'll be able to find it by going into the analysis toolbox again, and then overlay and intersect. So again, you're going to see this help menu that doesn't expand. Hold on. There we go. You have several features that overlap. We're going to intersect it, and then we're going to produce new polygons that represent the overlapping areas. Okay? So what we're going to do in order is we're going to choose the layer that the population or the polygon layer underneath, and then we're going to choose the ion buffer on top, and then we're going to just choose again what our output is going to be. So we'll choose the location. This will be our intersected, and I'm just going to call it intersected station. Intersection station India. Okay, save. And we're going to hit OK. That's going to do its thing. Did I do that right? I hope so. Maybe not. I don't think I did. Did I hit the right tools? No, there's nothing there. We're going to do that again. We're going to hit the population employment, the city type. We're going to choose our LRT buffer, or dissolve buffer. And then we're going to call this section area 2. It's weird that it didn't work. I'm going to check that that's correct. Yeah, that should be correct. Empty output generated. I don't know why it's doing that. Well, that's why we have a backup map. I'm actually not sure why it's doing that. It should work. Maybe if I try reversing the rank. Then 10.3. My balance journal attributes. Conflict between map and output. Okay, so there's an issue here, and I'm not sure what it is. I'm going to open the file that I was working on earlier. Sure. So that we can move on to the next stage. If there are any issues with Intersect that you guys encounter, and I'm going to take like 2 more minutes of your time. If you encounter any more issues with Intersect, please let me know, and then we'll try to solve it together. So once you run the Intersect tool, it should look like this. You'll see the underlying polygons have overlapped with the station area buffers that we've created. There's a different name here, but what we're going to do what we're going to notice is that once you've done the Intersect, it will combine the attributes from the polygons below it. So all of your population data and your density data, or population and employment data, and also the you'll have like your new buffer zones as well. So what might be useful here is if you were to have already calculated your population density and employment densities, so this is something that we did in the last tutorial, if you have the density of like in per kilometers of how many people live in each zone, then you can actually calculate a new area which includes your buffers, or exclusively considers your buffers, and then calculate the new population that comes from that. So what I did was I added a field. We're going to call this new area kilometers, and which is just a replication of that. We'll do double. So this is a new field. We're going to calculate the new geometry because all of these files represent the buffers. We're going to deselect, and we're going to calculate by calculating geometry. Hit yes. We're going to do area. We're going to choose square kilometers because that's how we calculated our density earlier. And now we have a new area in square kilometers. And then we're going to create a new field so that we can put in new maps. The population, or say employment, in station area. And this will be a double. It's too long. We'll just call it employment S. So station. You'll find that happens sometimes. And then we're going to calculate geometry, or do field calculator. And in order to find our new employment data, we're going to have our employment density, which we again calculated last time, based on the previous areas of all the polygons that we had, times the new area. So multiply by the new area kilometer, which we just calculated, is going to equal our new employment figures. Or did I do employment? Which one did I calculate? Field calculator. Yeah, employment. So employment density times my new area in kilometers gives me the new employment that will be caught in my LRT catchment area. And to find the total, just hit statistics. And your sum is right here. So based on this, if I were to use the LRT route that exists in Kitchener-Waterloo on my new population employment map, I will have captured effectively 267,000 people, 623 people. Cool? So that's how you figure out how many people are in your catchment area, whether that be employment, population, or literally any other variable. Cool? Let me know if you have any questions. I'm going to end it there, and then we'll post this online.